Hello everyone, welcome to Elite Weather. My name is Mr. G. I am your meteorologist, but today in this video we are not going to be talking about the weather. No, we are going to be talking about the images from the James Webb Space Telescope. We got 5 images that we're going to look at and explore. One is going to be of the Carina Nebula here. We got the Southern Ring Nebula, SMACS 0723, which is a galaxy cluster here. We got Wasp 96b, which is a gas giant that's about 1,500 light years away. And we got Stephan's Quintet, which is a whole bunch of galaxies in this galaxy group that is going to be colliding into each other. It's going to be a whole big mess out there. All these guys are kind of merging together, so that's pretty awesome. So let's jump and take a look at some of those pictures, right? All right. The first one is going to be the deep field image taken by the Hubble Space Telescope. Now, we all remember the images taken by the Hubble Space Telescope, I believe way back in like 2014 or something like that. It took that deep field image and we saw this. It's beautiful. Look at all of those galaxies. Now, this picture, this image is only about the size of a grain of sand at the tip of your finger extended out like this. If you were looking at the sky, but only the size of a grain of sand or rice on the tip of your finger extended way out like that. That's how small that image is. And there are over 100,000 galaxies just in this one image. Now, these things here with these bars on them, these are actually stars that are in our galaxy. So that's a star in the Milky Way. We have all of these galaxies. And I'm going to zoom in on this picture. This is a closer image because there's something I want you guys to see as we look at this. Now, do you notice these streaks and all of these going on? All these here. There's one there. There's one here. There's a couple right here. You see all of these like streaks that look like what that is called gravitational lensing. And you were looking at galaxies that are all at different distances. So you got some galaxies that are in the front, but galaxies behind them are like, hey, don't forget about us. We want to be seen too. So what is happening is the light from those galaxies is warping around the galaxies in front, which is allowing you to see some of the guys in the back. So this is not a trick by the James Webb Telescope. This is the universe doing this. The actual universe is doing this. This is the light bending around objects that are in front of the object that light's originally coming from. This is looking back 13.1 billion years back into the past. Some of the light from some of these distant galaxies, you see these little small specks. These are galaxies really far away, and the light that from those galaxies have taken 13 billion years to reach our telescope here. Now, what's special too about this image is the James Webb Telescope only took this image over a matter of hours. I heard 2 hours and then I heard 10 hours, but it's only a few hours where it took the Hubble 10 days to develop its deep field image. This is 2 hours, 2 to 10 hours on the James Webb Telescope. So imagine if you left the exposure on the James Webb Telescope open for 10 days. Imagine how crazy this will look. It would probably be too hard to identify anything because it would bring stuff so far back from to the Big Bang possibly, and that would just be a big huge ball of gas. It would look chaotic and you probably wouldn't be able to identify anything. But look at all of those ridiculous galaxies. Oh my God. I could just stand here and cry. This is so unbelievable. When people think that if we're alone in the universe, I think not. But anyway, let's take a look. Okay, here is a combination. Here is a comparison of the Hubble. I'm going to stand right here so you can see. So we see the Hubble on the left and we're seeing the James Webb on the right. Look at the difference. Look how closer some of those galaxies look. Look how bright they are. So people who are saying, oh, it doesn't look any different than the old one, it looks the same. You need your eyes checked, go see your eye doctor, have your head, your everything checked out, because if you think that, then you are cuckoo. So anyway, let's move on. And here we are looking at the Carina Nebula. Now, this here is the this is birthing stars. Now we go back to the first thing here. This is our Milky Way galaxy, right? This is what the plane of our galaxy. This is the Carina Nebula. This is where it is in our galaxy, right? So let's go back down to the Carina Nebula, and we are seeing how beautiful that is. Now this is birthing stars. Stars. This is all of the materials that our planet's made out of. Our solar system was birthed out of something like this. So this is all of the stuff you and I, people, are even made out of. Every element in the universe is in something like this. So everything that goes into creating stars, planets, the life on planets, there's water in this, there's oxygen in this, helium, hydrogen, every kind of gas and element you can think of is all mixed up in this thing. And you see these bright white, that's brand new stars that are being born. These stars are older. You see the yellow ones and the older stars, but the white ones are the newer stars. And you see all of these young stars is just popping up out of this. This is pretty spectacular stuff to look at here. Now, this is what I wanted to see. This is what I'm excited for James Webb Telescope. Now, we are looking at an image of Wasp 96b, which is a gas giant around Wasp 96, which is about 1,500 light years away from us in a completely different solar system. You are looking at a planet from another solar system. Look at that beautiful gas giant. You can see the atmosphere. Now, this is not a direct image. This is a spectrometry image of the atmosphere, and this is based on the light. We can tell what color it is based on these things here. This is measuring the water vapor. So it's water vapor in the atmosphere of this gas giant. So what Webb is going to do is measure the atmospheres and look at the atmospheres of the planets, because based on that you can tell what the planet looks like, what's it made of. You can tell whether it's life on that planet, because you'll look for certain gases, and those certain gases, different gases will emit different types of light when the telescope hits it. So you have to catch the planet as it when it's transitioning in front of the star, because you want to see the edge of the atmosphere. You want to see the glow of the atmosphere of the light from the star focusing through and around that light from the atmosphere. This is why you see that glow around the edge. See that big, beautiful atmosphere on a gas giant. Just imagine how much water is in the atmosphere. So because of that, we think there's clouds in the atmosphere. And so they depicted the clouds and haze from water vapor in the atmosphere of this beautiful gas giant. And this is a pretty good representation of what that gas giant actually looks like, because based on all of this right here, this data, it's going to really tell you what that planet looks like, whether or not it's going to be rocky world with oceans. You'll know if it has oceans, rivers, lakes, all of that kind of stuff based on the light that you're going to be getting, because this is all infrared light that's shining through and on this planet. So because of that, we can see how beautiful that gas giant is. And I cannot wait till they start to show what some of the smaller Earth-like planets are like. I would love to see those atmospheres, and this, I think it's performing better than I thought it would, honestly, to be completely honest with you. Now we are looking at the Southern Ring Nebula, and this is a star that has gone supernova. So it's blowing off the outer rings of the sun. Basically, our sun is going to do this in about 5 billion years. It's going to blow all of its outer layers off, become what's called a red giant, and then it's going to blow all of its layers out and create this nebula, and that is what's happening to this guy here. But I'm going to show you, look at that. That looks like it's one star. I'm going to show you something. Now, what you're looking at it from what is called, this is the near infrared, this is the mid infrared. Check that out. This is a binary star cluster. It is a binary star, and one of those stars is going supernova and is blowing off its outer layers. I don't know if both are. It might be both of them, but probably about the same age. So we got this binary star that is going through some pretty wild stuff. That our sun, and unfortunately, this is how our solar system is going to come to an end in about 5 billion years, because our sun is halfway through its life cycle right now. Now we are going to be looking at that quintet here, and you're seeing all of these galaxies that are all kind of merging. They're really kind of like passing through each other, and you're going to be seeing the black holes from these guys merge together. You got supermassive black holes that are going to possibly, some of them are going to become supermassive black holes, even bigger, because these guys are all going to be rotating around each other, and they're going to eventually merge together. You're going to see stars colliding and all kinds of hoopla. So if you are in a society that's living in any one of these galaxies right here, I don't know, your things, you guys, it might take billions of years yet. It's not like going to happen tomorrow, but those guys are merging together, so you will see some of those black holes merge as well. So that is really beautiful. I mean, look at that near infrared image. Look at how beautiful that is. I mean, wow. Just imagine that. Wow, unbelievable. All right, so that's a look at everything. I think we got it all here. Let's go back through once again. There's our Southern Ring Nebula. There is another shot of it. There's my favorite, the Wasp 96b. I'm all about the planets because I'm a planetary science guy. So that's what I'm all about. I love that. And this is really awesome too, because it's birthing planets and stars. And that there, wow. Just think of how many planets is in all of that. This, oh my God. That is 100,000 galaxies in this little tiny picture. Oh my God. I mean, wow, man. Okay. So that is it, guys. That was a look at the images from the James Webb Space Telescope. I'm Mr. G, your meteorologist and science guy. So anytime anything interesting like this happens, we're going to make it a video. Anytime the James Webb does anything, if it blinks, I'm going to make a video about it. So we're going to be seeing a lot more James Webb Telescope excitement over the days and years to come, hopefully. So thanks for watching me. I will see you guys all in the next video. Thank you, and have a beautiful day. Bye-bye.